All right, so let's take a look at Cura right now. So here's a fresh copy of Cura, just with a generic PLA profile and set normal, right? The normal recommended Cura settings. This is nothing, right? This gives you no real things to adjust over here. You have your infill that you can set. You can pick your pattern. You can set how thick you want the walls to be, turn on whether you want support and adhesion. You can't even choose what type, whether it's a brim or whether it's uh, a raft, however you want to do that. So if we go over here and open up the show custom, you'll see we have a little bit more, right? Let me pull this down so we can look. So we have a few more settings, right? You can actually open up each one of these and you can set your wall thickness, and if you want any sort of horizontal expansion to account for holes, shrinkage, that sort of thing. You can set your top bottom, how thick you want them to be, or how many layers based on your layer height. You can change either of those numbers. They will change each other. Um, your infill, you can, just like it was in the other screen, you can set a percentage, you can pick your pattern. I'm a big fan of the cubic subdivision. Actually, I like adaptive subdivision, but that's not in Cura. So the cubic subdivision is not only one of the strongest infills, it's also rather quick, and it, um, it never goes over the same place twice. So you're a lot, like when you use grid or line infill, I find that's a lot of times when I'll get little artifacts or blobs or the occasional string or something that when the print head is jerking around, it'll grab something, and that can break adhesion too. So I found any infill that doesn't go over the same spot over and over helps. So your options there would be um, the trihexagon, cubic subdivision, octet, um, gyroid, lightning. Lightning's weird. It's super fast and doesn't use much material, but it is not strong. So I usually use the cubic or cubic subdivision personally. Gyroid's really good too, and people tell you it's strong as shit. I've done some stress tests. It definitely isn't. The cubic subdivision is the way to go for infill. And so here you have material temperature, right, and then your speed. This is great. So here you can set your actual print speed. And it looks like I have a couple options. You won't have all of these options. I already turned a couple on when I was prepping for this. I'm sorry, but we'll go through how to do that in just a moment. And in fact, let's just do it right now. So you'll see that when you look at yours, you're just going to have print speed, and that's it. It's not going to have any of this. In fact, let's go turn that off, and you can see what's up. Okay, so this is what yours is going to look like. I'm going to go through these real quick and then we'll hop in. So you have your travel. I would recommend turning on retraction to make sure that you're not stringing, especially with the PETG. It is fairly hygroscopic, and I've never had a problem with adhesion because of moisture content in the filament, but it can get kind of stringy. Um, I also like Z-hop when retracted. What that is going to do is it's going to pull the nozzle up on the Z when it does the retraction. It's going to help with stringing and help with knocking things on the plate, that sort of thing. Under cooling, you're going to have enable print foot cooling and a fan speed. That's it. You're going to want to make some changes here. Support is how you want to add support. Build plate adhesion, you get to pick what kind of adhesion you want. Do you want a skirt, brim, raft, none? However you want to handle that. But again, there are no settings, right? You're just turning those on or off. You don't really know what they're doing. So if you look at this on every one of these little categories, there are these sliders here. So we'll start at the top under quality, and we'll just click these sliders. Now this is going to open this preferences window. Any of these boxes that aren't checked, those are additional settings that you can tweak in Cura for your prints that aren't activated in this list by default. So if you look down, there are literally hundreds and hundreds of settings that you can go change to really dial in your printer. Some of the important ones we're going to look at right now. We'll start with quality just real fast. Um, Really, the layer height here is going to be your big thing. Initial layer height can help if you're doing very fine prints at like a 0.08 or a 0.1 millimeter layer height. Having a nice strong thick first layer can be good, so you can turn this on and change your initial layer height right to like a 0.2 or whatever. Um, Line width you're not really going to mess with unless you are running into issues or if you switch nozzle sizes. And that's going to hold true with the wall line width and that sort of thing. So really on quality, that's it. Those are the only two that I feel like you would really want are layer height and initial layer height. So let's go on down to walls. Again, this isn't bad. Wall thickness, wall line count, and horizontal expansion turned on. If you want to, if you want to adjust that. So um, really that's all you're going to need there. If you're running into weird issues with your walls delaminating from each other or not sticking to the infill very well, then you might want to um, tweak some of these settings. But for the most part, I don't have any issue just using just kind of the defaults. One other thing to consider if you're getting weird artifacts or bad layer lines, one thing you want to check is under wall ordering. You want to make sure that it is going from inside to outside. If you print the outside walls first, then a lot of times the heat and the movement from doing those lines right next to that outer line will cause it to swell or warp a little bit, and it can give you worse lines. So always make sure that you're doing your inside lines first and doing your outside lines last. That should be how it is by default, but if you're noticing some weird issues and you can't seem to pin them down, you can check on your wall ordering and see how that is going to go. One other thing that I will put that I will talk about real quick is this print thin walls. So I don't know if you've run into it yet, but if you ever print anything and it has a fairly thin spot, whether you're doing letters or a little border around something or a really fine connection somewhere, uh, and sometimes the printer just doesn't print a section. That is because it is detecting a wall that is thinner than the extruder, so it can't print it thin enough, so it just ignores it. Whereas if you turn on this print thin walls right here, this will, regardless, it will print any wall on the print, regardless of if it's too small or not. So any walls that it deems too small to print, it's going to print them anyway. They'll just be a little bit wider. So that's something to notice there too. You can always do check your seam alignment as well uh, to see. If you're putting a seam on a really sharp corner and that's where it's reading the seam, yeah, that's probably visually that's probably the best spot for the seam to be, but it can cause adhesion issues, right? Because you're having that gap there and you're already having a problem with a corner coming up. So you can play with a few of those. I usually just leave it on user specified. I don't use Cura anymore, so I don't remember what I did there, but I think I just left the Z on what it is. I didn't even mess with that in Cura. It was never an issue for me. Top bottom, you can go look. These will change. These can change your infill and the pattern that they look like and how thick they are and how fast they go and all that great stuff. Feel free to flip through that. Ironing is when you're going to put the nozzle right on the top of the print and just run slow and with a very, very fine, small amount of extrusion to kind of polish the top of your print. I generally don't care what the top of my prints look like because I'm doing a lot of functional stuff, so I don't use that. So infill, really the only thing I mess with here is my density and pattern. I don't change a whole lot here. So you can leave that at default, or feel free to scroll through, play with all your stuff. Look at all the settings and see if there's anything that you want to mess with. But I'm just giving you some pointers on printing the PETG. So now here's one under material. You have this printing temperature. Let's close some of these and let's pull up material so we can see what's up. Okay, so under material, we have material, you have your print temperature, your build plate temperature. Awesome. I had talked about starting Oh no, I had talked about fan speed in the Facebook post, but we can talk about temperature too. So sometimes if you want to make sure that that first layer goes down really, really well and is really sticky, you can run it a little bit hotter. So if you turn on this build plate temperature initial layer, uh, then you can set the temperature. So say you're printing PETG, right, and you're printing at 75 or whatever, put that first layer down at 77, and it'll get a little bit better squish, a little bit better adhesion. Uh, Up to you. Um, it is what it is. Some of this is trial and error, and there is no easy fix. There is no one size fits all for printer, right? There are a lot of different environmental conditions, and the filament's different, and people have different printers, and there's different amounts of vibration, and the Z offset's a little bit different, and the build plates are different. So you just kind of have to play with some trial and error. But these are some best practices to look at. So, really, there in material, I'm not going to mess with a ton. If you're having flow issues, you can go in and change some settings on your flow here after you calibrate your E-steps and make some adjustments. But for now, you don't really need to mess with that. So here's a big deal one, right? We're going to talk about speed and we're going to talk about cooling. I think those are your two main issues with your PETG, so that's what we're going to look at right now. So under speed, if we look at speed, you got print speed, and that's it. That sucks, right? So the default, at least for mine, is 250 millimeters a second. That's fast, way too fast for what you're doing. My printers supposedly can go up to 600 millimeters a second. I've never taken them faster than 400, and typically I keep them around 100 or lower. If I'm printing large functional parts, I might speed them up a little bit, but I like to go slow. You have a lot less risk of catching a print and pulling it off the plate. Uh, less, I'll say less stringing. There's a caveat to that, but let's just leave it at that. So I try to go pretty slow. For my PETG, I've got some rapid stuff that, again, supposedly will go up to 600 millimeters a second. The fastest I've run that at is 4, and most of the stuff I run somewhere between 50 and 100. I would start down around 50 millimeters a second. That's pretty slow. Um, well, by today's standards, that's pretty slow. That's really not even that bad, but I would start there and see how that works for you. You'll notice that you have some options here under speed. You can turn on all of these options and you can control how fast the printer is going at any given motion, right? So when it's doing the infill, how fast is it going to go? I know a lot of people have problem with their infill, and that's when they get hairs and stray fiber, stray pieces of plastic or little boogers that get caught and knocked off the plate. So you can slow your infill down to make sure that you print a little slower on your infill, and you can change how fast it does the walls and the top and the bottom and all those speed options. For the most part, I don't mess with these a ton. What you see here that I've got turned on is about it. I like to slow my outer walls down sometimes. So if I'm printing at, say, 100 millimeters a second, then I would lower that wall speed. You know what, 65, I might just leave it at that. That's the default it gave me. Oh, because that's an average. So on the outer wall speed, I'd probably run it at like 75. Inner walls, I care less about. They can go full speed. Uh, Top and bottom speed is another one I use. I like to slow down for my top and bottom. I slow down for my initial layer anyway, which we're going to talk about here in just a moment. So now if we scroll down a little bit, you have a few other speed options. And if we look at travel speed, that's how fast it's going to move the print head when it's not printing. So when it's moving from point to point to print in between, between areas of the model where it's going to print, it's how fast it's going to move. I've found that turning that down can save some knocked off prints too if you're running into issues there. I usually keep it around 100. The default for a lot of slicers is like 350, which is fine, but when that thing zips across, if it's not perfectly level or there's a little artifact somewhere in the model, it can definitely catch it and rip that print right off the plate. So, or pull up a corner. That sort of thing. So I try to keep my travel speed about the same as my print speed just to avoid any issues. Now this next one in the speed, you have this initial layer speed. This is what I was talking about in the Facebook post. So you have your initial layer speed. but you can also control the print and the travel separately. So if I turn on this initial layer print speed, let's set my first layer at 25 millimeters a second, go nice and slow with it, and then I can tell it how many layers, which is number of slower layers right here. You can tell it how many layers you want it to be slow, and it's going to just take an average and give you a gradient up. So it's going to start at 25 millimeters a second, and if I put in, I want 3 slow layers, so it's going to do the first layer at 25 millimeters a second, the second one at like 40 or 42.5, and then it's going to do it'll do the second layer like 30 and change. It'll do the next layer at like 50, and then it'll be up to 60 on the fourth layer. So you'll have 3 slow layers where it slowly ramps up the speed. You can do the same thing with your fan, which we'll talk about here in a second. Other than that, for speed, again, these are going to be just settings that you can go mess around with if you're trying to get it to jerk better and pull off strings and all kinds of great stuff. I don't really usually mess with the jerk. I find I create more issues when I start screwing with it than I did before. Travel. Let's look at travel. This is another good one that can help, and it's little things. Retraction. You're going to want to make sure you have retraction turned on. That should be on by default. Um, if not, make sure you turn on retraction. You can also go in and dial in the retraction with these settings, right? How fast is it going to retract the filament? How far is it going to retract the filament? And what that retraction is when it's moving from point to point, when it's traveling, it's going to suck that filament back up into the print head a little bit to keep it from oozing and stringing and getting little spots stuck on the print. This distance is going to vary greatly depending on your extruder and your delivery system. That's something you're just going to have to play with. I usually like mine about 0.6, but I have some buddies that have enders with Bowden tubes, and they have to retract, like 5-6 millimeters to get the results they want. And if I do that, then my print is garbage. It can't recover. So it's different. Well, again, there's no one size fits all. Uh, so one other thing under travel, there are a couple that can be really important when you're dealing with adhesion. You have this avoid printed parts when traveling and avoid supports when traveling. So this is going to force the print head to go around. So say you have, this square piece here. Let's pretend this box is printing. So it's going to print the outer line, print the outer line, print the outer line for the wall, and then it's going to stop. And say it wanted to go print a little section over here. Well, then normally, right, it's going to go and just go right there. Whereas if you tell it to avoid, it's going to go around the outside and be a lot less likely to catch on anything and to leave oozing plastic anywhere on your print that could cause cause it to catch and pull things off. Uh, so yeah, I like to use those a lot. I always have on avoid printed parts when traveling and avoid supports when traveling. I know people will dog it and say, hey, you're adding a lot of extra print time. It's really not that much extra print time. And I'll tell you what, if I have to add 10 minutes to this print and save 4 hours from having to print it again, I feel like that's totally fucking worth it. So yeah. So your next big thing, and this should be the last one you have, is this is cooling. So under your cooling, if you just open the default menu, you got fan speed. Do you want cooling? And how fast do you want the fan to run? Right? Or, how much power? 100% power. How fast that actually is going to vary from printer to printer, extruder head, fans, all that. But do you want it to run at 100%? Whatever. So if you look under here, you have some options for regular and maximum. So this maximum, it's gonna speed up. If you set the regular fan speed at say 50, well then normally when this printer's printing, it's gonna be running the fan at 50%. But if it goes to do an overhang or some bridging or that sort of thing, then it might crank up the fan speed to make sure that that part cools properly. I don't mess with that ever, right? I have a set fan speed, and then I'll do initial fan speed, I do regular fan speed at height, and so I'll touch on minimum layer time. We'll talk about that a little bit. So initial fan speed, right? 0%. That means that it is going to start with zero fan, right? It's going to have the fan turned off for the first layer. So it's going to do one layer with no fan. Now on the next layer, it's going to jump up to 100%. PETG handles warping from high temperatures much better than PLA. You don't need a lot of fan with it. In fact, running the fans is probably what's causing your issue. Those parts are cooling too fast and they're warping, and you don't notice it at first because the first few layers hold well. But imagine there's a lot of there's a lot of tension in that plastic, despite the fact that it's molten. It's still being stretched out across this bed. So imagine taking, I don't know, 10 pieces of electrical tape about 6 inches long, and you stretch one and stick it down on the table. Sticks great, looks great. And then you take the next piece and you stretch it down and stick it over that next piece. Still looks pretty good, stuck down great. Well, as you keep doing that with that tape, eventually those edges of that tape are going to curl up. And because there's so much tension in the middle that was never resolved. So, allowing these things to cool slowly so they don't contract really fast and pull off the plate. They can actually have time to stay molten and stick to the plate. Can be a big deal. So um, I don't run any higher than I don't run any higher than 30 on my fan speed for PETG. And that's what, and I usually do about you can do it by layer, by height, or by layer. So if you turn on this regular fan speed at layer, then you can go tell it, hey, which layer do you, how many slow layers do you want? So if I put this on 5, then the first 4 layers are going to be, it's going to be, 0, 8, 16, 24, and then by layer 5 we'll hit 30%, and that'll be my max fan speed. I think that's probably your biggest problem, is your part cooling. And I may have been a bit verbose about the rest of this, but it sounded like you could use the help, so I figured I'd throw it your way. Other than that, you have support settings. We're not going to talk on that right now. Build plate adhesion. So you have your brim, which is going to be a thing that you're going to want to do, right? So if you let's go down and look at build plate adhesion. So right now all you have is type, right? Brim, skirt, raft. So a skirt, it's going to put a line or number of lines, a bit of a way out from your model, and it's basically just a good chance for you. If you do it a few walls thick, then you can watch and make sure you're level and make sure your squish looks good, and you can adjust that while that skirt is printing. It also gets any blobs out of the nozzle and make sure everything's flowing good. So that's why you would use a skirt. A brim is going to actually put a border around the model itself that's barely touching, or within like a tenth of a millimeter, to help add adhesion. But that's fine. What can you do with that brim? How big is it? How does it act? What does it do? So if we go over here and look at the build plate adhesion settings over here, you'll notice you have a whole lot, and under here you have brim width, um, line count, distance, all of those things. So this distance is going to be how far away it is from the actual model itself. I find 0.1 to be just about perfect. Um, and then the line count is going to be based on the brim width. So right, that's 5 millimeters. So it's going to take it 10 lines to get a 5 millimeter brim around your object. Your other option is raft. I only use this in the most extreme of cases because it is a bitch to get the raft off. Um, don't use a raft. That is where it's going to print, uh, based on your settings, but 5 or 6 layers of kind of this cross-hatched loose infill pattern that it can use to print supports in your model onto. So the whole under your whole model will have a piece of plastic, and it's just a nightmare sometimes. So I try to stay away from the raft unless absolutely necessary. I do use a brim quite a bit. You can turn on location and you can tell it if you only want to do the outside of the model or if you have insets in the model, holes, inner areas to the model. You can turn on inside. If you turn on everywhere, it'll do outer and inner brims. I usually just use outside only. It's hard enough to get those things off sometimes, and I'd rather not have to dig it out of things. So that's pretty much it that I do with the brim. As said, I don't really use the raft. That should be all of the settings that you need there. So now I'm going to hop over into Blender real quick, and we're just going to show you a really fast trick. Hang on. Let me open a new file. Okay. So here we have our cube. I don't know how you model in Blender, whether you have your units set to 0.001 in millimeters or whatever. Determining the height is going to be up to you. I work in many different game engines and slicers, and many of them have different scales and different unit settings. I hate having to change it, so I've just adapted my use in Blender to each one. I know that in Blender, if I use the default settings, that I can just treat everything in meters and know that when I take it to Cura, it's going to be in millimeters. So if I look at the dimensions on this cube, right, it's 2 meters, so it's going to be 2 millimeters in Cura, and I've just taught myself that, so that's how I handle this. That's how I handle my scaling in Blender, if you're curious about this next part. So let's say you have um, this piece here that you're printing. I saw that you have a big square piece. In fact, let's scale this up so it's a little more accurate. Let's scale it by 100, huh? Let's make it 200 millimeters by 200 millimeters. Big flat square piece. Scale it up on the Z a little just so we can see what we're doing. All right, so you have this big flat square. So when you're printing, especially out to the edges, that heat bed struggles to keep the heat out to the edges. And that's why I said your little draft shield that you set up is actually probably going to be very helpful. Luckily on my Neptune, it has a segmented heat bed. It has multiple elements. It heats really, really well all the way out to the edge. So I don't have to have the enclosure for PETG. I haven't tried any like ASA or carbon fiber or anything like that. Which I would need an enclosure for. But so let's say, so it's very difficult for your printer to keep heat out here, and it is the most likely spot for things to peel up. But you'll notice if you look at your prints, it's never on an edge. It's always on a corner. So you can do a couple things to mitigate that the problem, right? This is a tiny point, so that cooling, it's just going to cool off way faster. Here out in the middle of the print, this plastic has a ton of thermal mass, right? It's gonna hold the heat really well, and you're not gonna have to worry about the adhesion. Whereas this tiny point that comes out to this point, any little air in the room, or just the fact that it's out in the air and the printer's struggling to keep the bed hot out all the way out to the edge, that could create some issues. So I'll show you a couple things you can do. First off, since you are doing the modeling yourself, if you select, oh, hang on, I need edges. So if you select all of the edges on the corner, actually, let me do this for you as well. Okay, just in case you want to see how I'm doing what I'm doing. So you have these corner edges. So if you select all of those, and then you can bevel them. And when you're making your bevel, you can use your mouse wheel to scroll up the resolution of the bevel. So if you round off any corners you can, that's first step. Step number one. That's really, really going to help with adhesion, because you're not going to have that sharp point. This rounded edge is going to hold a lot more heat than that tiny little corner. If that is not possible, or even if you do, if it is possible and you still have issues, then here is what I like to do. I'm going to add a cylinder. I'm going to move it up by 1 just to put it in the middle. I'm going to set the origin to the cursor. All right, so now if I look at the cylinder, I've got the cylinder, and I am going to, well, let's see. So currently this cylinder is 2 millimeters by 2 millimeters by 2 millimeters. So I want it to be, say, 8, 10, 12 millimeters wide. Let's say 10. So I'm going to scale it on the X and Y until it gets to about 10 millimeters. Doesn't have to be exact, and you can play with whatever sizes you want. And then I'm going to make sure on the Z, I want it to be 0.2 millimeters. That is my current layer height, 0.2. Well, I guess it's 0.15 in there in the profile that I was showing, but I generally print at 0.2 or zero point 0.1 depending on the model, but generally functional stuff 0.2. So I'm going to make this little disc that is 0.2 millimeters high, right? And then I am going to, I am going to move this cylinder to a corner. Going to use this like a mouse ear. We actually might even want it a little bit bigger. Now, you might not actually, because it looks like you're pretty close out to the edge of the build plate, and the real trick of this is what I'm about to show you. So now I have this awesome little mouse ear. I am going to mirror that on the X and Y. Whoops. To get one on each corner. Now, depending on how you handle Cura, um, you can do it. You can do a mesh fix, which will print this. And Cura's pretty good about just grabbing whatever's on the plate. If it's overlapping, it just prints it. So you can either Boolean these items um, to your object, so they actually cut in, and it makes a nice manifold mesh. Or you can just import it into Cura just like this, and it should be fine. I'm a sucker for making things manifold when I can. So we're just going to go ahead and, whoops. Oh, you know what? You know what I'll bet happened? Hang on. Apply that mirror. I think my normals were backwards. Let's fix that. Fix that. Oh, must be this one. Let's go look. What? Alright. What the fuck ever. We're just going to take all of this stuff. We're going to join it as one model. Turn off face orientation. Um, and then we're going to export it. Export this STL. You want to make sure you export selection only. And let's just go ahead and put this on tutorial ideas. I'm actually working on a course on modeling for 3D printing. Uh, so I got some ideas here. So selection only. We're just going to call this toot test, whatever. Export STL. Now, when I pull this into Cura, let's take a look at what's going to happen here. This is kind of cool. So let's grab this model. So here we have our thing that we made, and you see we have these mouse ears here. Now the beauty of this is, so if you add mouse ears to a model, say in Orca Slicer or with a Cura add-on, it's going to treat them just like a brim. So it's just going to go concentric rings, concentric rings, concentric rings, and then the brim's going to be concentric rings, right? So you always have these weak points between the lines. So if this thing really wants to peel off, these concentric lines, one layer high, aren't going to stop it from peeling off. You know, if that thing starts to cool funny and warp, it's going to yank those right off. Well, when you have these mousers that you made yourself, it's going to put whatever the infill, whatever the fill pattern is, right? So if you have monotonic, the, you know, kind of go corner to corner, 45 degrees, it's going to do the same thing on these mouse ears. It's going to put a wall around them, and then it's going to do fill. And so you don't have these concentric rings, you have a lot stronger connection. So then if you go in and actually add your brim, and when you add the brim, then it's going to put the concentric lines around it. and it's going to give you a ridiculously strong amount of adhesion to the corners, and it'll really, really hold things down really well. Um, I hope all of this helps, man, and let me know if you have any other questions.